All right, so we're going to do the distributive property today. Shh, quiet. So, let me show you how this works, okay? If I say 3 times 2 plus 4. Now, according to order of operations, please excuse my dear Aunt Sally, what do I do first? Yes. Thank you for raising your hand.
The thing inside the parentheses, basically 2 plus 4.
Yep, we're going to do the thing inside the parentheses first, or 2 plus 4, which is 6. And then I multiply by 3, correct? That becomes 18. Okay? Now, what the distributive property, what we've discovered is that the distributive property will give you the same answer. And I don't want to bore you with why, but just know that if I say 3 times 2, that's 6. And then 3 times 4 is 12. What's 6 plus 12? 18. So when we do algebra, sometimes I can't add an x or subtract 5 from x like we have here. So I could do the thing called the distributive property, and the distributive property allows me to continue to do the math and then solve for x later. So what I'm going to do is I'm going to distribute 3. So we have this expression here, 3 times the quantity x minus 5 plus 1 equals 2 plus x. Okay? So when I say, what's 3 times x? 3x, right? What's 3 times negative 5? Negative 15 or minus 15. Now, we're going to combine like terms. What's negative 15 plus 1?
Negative 14.
Negative 14, right? Combining like terms. Do you guys remember what a fancy word for negative 15 and positive 1 are?
Nope.
What are they called?
Below 0.
No, constants. Constants. What, do you guys remember the term? 3x is it's a variable term. Yeah, they're just blurting things out. A variable, a constant, blue, circle, tree. No. Variable means that it has an x or a y or a letter. And that means that that term will vary depending on the value of x or the letter. A constant does not vary. Positive 1 will always be positive 1 no matter what you plug in for x, because positive 1 does not have an x, so we call it a constant. So we added up the constants. All right, so now I want to do something, to move something on the other side. What do you think we end up doing? I have to subtract something from both sides. Yes. Kind of. So how would the problem is that I have a minus 14. So I'm trying to think of, I don't know if this confuses you guys or not, but what they want you to think about is that minus 14 is the same. In other words, if I subtract 14, that's the same as adding what? Adding what kind of 14? A negative 14, right? So if that's the case, how do I word that? It says I'm minusing. It says subtract something from both sides. What do I say? How do I write that in, you guys? Take a guess.
Now I should recall.
Mm-hmm.
Minus 1x on each side.
Yeah. Well, okay. So, good. You guys wanted to add 14. This is the challenge, right? We needed, if we were to move the 14, what I was trying to get you to see, and somebody blurted out, actually, they want to subtract the x from both sides first.
Oh, yeah.
Right? You'd find the smaller x. What I was trying to allude to is, do you put minus 14, or do you subtract x from both sides? Now, what was the clue? How'd you figure that out? You got a 2x here, right? So it'd have to be 3x minus x, which is 2x. Now, instead of subtracting 14, what do I do? Add 14. And when I add 14, what do I get? 2 plus 14 is 6. 2x here. If I divide this by 2, divide this by 2, x equals 8. Does that make sense? All right, let's do the next one. We're going to use the distributive property first. What's negative 4? Whoops. Oh, that thing went crazy. What, what the heck happened? What's negative 4 times k? Negative 4k. What's negative 4 times positive 1? Negative 4. And then I just tack on. Everything else stays the same. I just leave it there and tack it on. So what did we distribute, you guys? Yes. Thank you for raising your hand. Negative 4. So I'm glad that he raised his hand because I hear a lot of murmuring. It was negative 4, yes. Oh, it's okay. We have to remind ourselves. So now when I simplify, isn't this negative 4k, what do I put after that? Oh, we're simplifying everything to the right-hand side of the equal sign. What is negative 4 and negative 3? What kind of terms are those? Constants. And what is negative 4 minus 3? Or minus 4 minus 3? Yes. Close. Yes. Negative 7. Now, negatives are always hard for people. What you could do is you plug that in your calculator. If I say negative 4 minus 3, guess what I get? Negative 7. So double check it. Okay? Double check it. All right. So now we always move the smaller k. Well, they didn't do it this way. I would have moved the negative 7k. So let's just move this, the negative 4k. So I'm going to add 4k to both sides. Ugh, that's a lot of extra work. Maybe I am cranky. Ugh, textbook publishers. So when I do that, I get 5. And what's negative 7 plus 4? If you don't know, plug it in your calculator. Negative 7 plus 4 equals negative 3. But we can't forget the k, so that becomes negative 3. These cancel, and I'm left with negative 7. I need to move the 5 over to the other side, so I subtract 5 from both sides. Okay, that leaves me with, this 5 cancels with this 5. What's negative 7 plus negative 5, or negative 7 minus 5? If you don't know, put it in the calculator. Negative 7 minus 5. Negative 12. So I get negative 3k is equal to negative 12. Now I want to move the negative 3 away. It's multiplying by k, so I would divide both sides by negative 3. What's negative 12 divided by negative 3? Yes. You're close. It's actually positive 4. A negative divided by a negative. Now, again, if you're not sure, plug it in the calculator and check. Positive 4. Okay? Positive 4. Are there any questions on that? Okay. So I think that